Hi guys, this is Bergen. I just wanted to let you know that this is where it's going to really start to really be very important that you are knowing your multiplication facts. So starting on lesson 1.4 is when it really comes into play, and then it starts getting progressively, you're going to need it progressively more. Throughout the rest of this fifth grade, all these chapters. So you're going to really need to know your multiplication facts starting like now. So I'm just letting you know, if you need any help on that, you could go to www.multiplication.com to help you learn your multiplication facts. That's one way also that you could always do, flashcards. You can make up your own flashcards. That's totally up to you. But it's really important that we start knowing them now because we're going to need them. Now, I am going to flip it over because we are going to be doing lesson 1.4. And this is what lesson 1.4 looks like. We're going to be talking about powers of 10 and exponents. The one nice thing about powers of 10 and exponents is that there's kind of a trick to it. Next year, you're going to go and do exponents again, but now it won't be with powers of 10. But with powers of 10, there is a trick. So I'm going to be showing you that. So first of all, it says expressions with repeated factors such as 10 times 10 times 10 can be written by using a base with an exponent. The base is the number that is used as a repeated factor, and the exponent is the number of how many times that base is going to be used as a factor. So here they're telling you that 10 is a base. 10 means you're going to be using that number and that number only 3 times is what that exponent is saying. So you're going to write 10 3 times. So 10 times 10 times 10, and then you're going to multiply each one of them. Now, the one good thing is here is you could look and you can look at how many zeros are at the ends here. There is 1 here, 2, 3. So you can just say 1, 2, 3, and then you're left with 1 times 1 times 1, which is 1. So it is 10 to the third power. I will show you what that one trick is as well. I'm going to give you another example. We'll say 10 to the 5th power. This is what you do. What you do is you're going to be using the base this time, which is 10. Again, the only ones that we're going to be using this year is 10s. So that's what's nice about this year. Next year it's going to be totally different. But you're going to be writing that 10 5 times. So 10 5 times. And then you are going to times them. And how we say this is we say 10 to the 5th power. Some people say the 5th power of 10. I'm always going to say the base first. 10 to the 5th power is how I would say this. This one would be 10 to the 3rd power. So, I mean, that is up to you how you say it. What they're giving you is the 3rd power of 10. And then exponent form means they want an exponent there. So it'd be 10 to the 3rd power. So you could say it 10 to the 3rd power. And I will give you that as well for you to say that. I'll give you that credit if you can say either of these 2 ways. I always say the base first. Some people say the exponent first. I say the base. So that is up to you how you want to go ahead and say that. So 10 5 times. 1, 2, 3, 4, 5. All right, so The one thing that you could do again is you could count all the zeros first. 1, 2, 3, 4, 5. So you could say, all right, I'm going to put 5 zeros. 1, 2, 3, 4, 5. And then do 1 times 1 times 1 times 1 times 1, which is 1. So then you go 1, 2, 3, comma, and then 1, 2, 3. All right, so then your answer is going to be 100,000. Now here is the trick to make that a lot faster. So the trick is, I'm going to write that right over here. So say you had 10 to the 5th power again. All right, but I'm going to show you the trick now that you know what the answer is supposed to be. So the trick is you bring down the 1, and then this is going to tell you how many zeros to put in. So it is putting in 5 zeros. 1, 2, 3, comma, 4, 5 with a 1. So your answer, that's just another way to do it. Your answer is 100,000. This works for only powers of 10, which is the only thing that you'll be using this year. So it works out, and that can be a trick that you use. I'm going to do another example, 10 to the 2nd power. You should know that it is writing 10 2 times and then multiplying it. Well, 10 times 10 is 100. But if you wanted to use the quick way, you could do this. 10 to the 2nd power. First, you just bring down the 1. And then you say how many zeros there are. Well, there's 2 zeros. So then you're just going to add 2 zeros. So that would be 100. It's just a fast way to do it. But it only works for powers of 10. But the one common thing that I see a lot of people doing, and I want you to write this in caps, to not do this. So don't do this. I want this to be a side note. So important, because a lot of people still do this. A lot of people think that this is so easy because all you do is you do 10 to the 5th power. They write it like this: 10 times 5. Don't do that. If it was that easy, then that's what they would have wrote. But that is not that easy. I don't want you guys doing that. So absolutely don't do this. You are simply writing the base that many times and then multiplying them. Or you can bring down the 1 and add that many zeros, going to be your answer. All right, so this one is saying, it's showing you 1 cube, and they want you to write what is 10 times 1,000 written as an exponent. So we're going to talk about that in just a minute. So right now it says a 1 is 10 to the 0 power. Now why is that? Because here is that 1, and then how many zeros are you going to have to it? You are going to have 0 zeros. So therefore it is true. 10 to the 0 power is equal to 1. Next, they will show you 10 to the 1st power. Well, 10 to the 1st power is a 1 with 1 0. So it's just like that. Here, 100 can be written as 10 times 10, or you could also do it 10 to the 2nd power, because there is a 1 with 2 zeros. Here is another one. 1,000 can be written as 10 to the 3rd power, because it is a 1 with 3 zeros. So this one is saying first, how many 1s are in 1? Well, you should say how many 1s are in 1. There's only 1 1 in that. How many 1s are in 10? So if you looked here, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 10s, 10 1s, and 10. How many 10s are in 100? So how many longs are there in this 100? column. Well, you should be saying there should be 10 of those. Now they're saying, now how many hundreds would it take to make up this 1,000? Now keep in mind this right here is all 1. So then how many of those are there to make up this 1,000 block? And there are again 10 of those. Now the question is, how many thousands are in 10,000? So now if we had 10,000, 10 of these, how many would it be to get to 10,000? So there are, how many of these cubes make up 10,000? So that would mean you would need 10 as well. So in the box at the right, draw a quick picture to show 10,000. We're not going to do it that way. I'm going to have you guys do the quick way. So the quick way is, first of all, they give us this part. So that is 10 to the, how many zeros are there? There's just 1, so it's 10 to the first power. And then you're going to times it by how many are here? So that is 1, 2, 3 zeros. So that is a 10 to the third power because it has 3 zeros. So now how many zeros is that total? That would be 1 here plus another 3. So that would be a total of 4 zeros. So that should come to 10 to the 4th power would be your answer there. So that is how you figure out that. We're going to do lots more. So if you're confused, it's okay. We'll do lots more. Here we go. So next, it is saying hummingbirds beat their wings very fast. The smaller the hummingbird is, the faster the wings beat. The average hummingbird beats its wings about 3 times 10 to the 3rd power times a minute. How many times a minute is that, written as a whole number? So what they want you to do is to multiply 3 by powers of 10 until you get to where it wants it to be. So they're going to start first at 3 times 10 to the 0 power. Now remember, 10 to the 0 power just means a 1 with 0 zeros, which is just 1. So what is 3 times 1 going to be? It is going to be 3. Next, now they want you to do 10 to the 1st power. So that means a 1 with 1 0, which is 10, and that's how they got that. So it is 3 times 10. What is 3 times 10? That would be 30. Next, this is saying now you're going to take 3, and then you could either think of it as 10 written twice and then multiplying it, or quick way would be taking the 1 and then adding 2 zeros to it. So this is the way that majority of the kids like to use it. They just do the quick way. So what is 3 times 100? It would be 300. Next one, the other thing you could do is you could do 10 to the 3rd power. You could write it 3 times, 10 3 times, and then multiply that as well as that 3, because that's still part of it. Or quick way is a 1 with 3 zeros, 1, 2, 3. So that would be 1,000 times 3, which would be 3,000. And that is exactly what it wanted. It wanted a 3 times 10 to the 3rd power. So it would be the average hummingbird beats its wings about 3,000 times a minute. All they did was they, were just showing you the pattern on how to do that. You don't have to do it that way. I think that's just a long way to do it. But they were just showing you what's going on between the zeros. We don't have to worry about this part because we do see a pattern. This is how many zeros there are in that number. So 10 to the 3rd power is 3 zeros. and then timesing it by 3 would be 3,000, because this was 1,000 times 3. So here is the next thing. Now we're going to write this in exponent form. Exponent form means you are just going to have it be like this kind of a form. It needs to have an exponent on top. So the exponent form is what is being multiplied both times. What is the base number? Well, the base number is 10. And then how many times is it being multiplied? It is being multiplied twice. So it is going to be 10 to the second power. So that is what the word form is. You can choose to say the power first. Sometimes it tells you to do the power first. The second power of 10. I don't ever say it like that. I always say the 10 to the second power. All right, here is the next one. Now, what is the base here? The base is that number that is being multiplied every time, being repeated. The one that's being repeated is 10. And how many times is it being multiplied? It is 4 times. So that is why it is 10 to the 4th power, because it is being multiplied 4 different times. So the word form of this is 10 to the 4th power. So that is what you would be writing here, 10 to the 4th power. All right, next, now they just want you to find the value of this. You guys can use the quick way. You guys can write it out like this. 10 to the second power just means you could write it 10 twice and then multiply it. What is 10 times 10? Or you could do how many zeros are behind, which are 2. And then what is that left with? 1 times 1 is 1. So that is how you could get the answer there. Or you can use the quick method of 1, and then this is how many zeros, is just another way to do it. Usually the kids choose this way, but you could do it either way, does not matter. All right, so this one, you should be looking for exponents first. So this is looking at the 1 first, and then this is telling you how many zeros to add on. That would be 2. So that is 100 times 4. What is 100 times 4? That is 400. Next, this one is saying 10 to the 3rd power. 10 to the 3rd power is 1. And then this is telling you to add 3 zeros to it, which is 1,000. So 1,000 times 7 is 7,000. Now, the other thing is that I do want to go over very quickly is, you remember in lesson 1.1 when we were talking about place value and how you know, each place is 10 times the other one, just like this. Do you remember us talking about this? Each one is 10 times the value as you go. Well, here is something to look at. Do you see how it is 10 to the 3rd power? That actually means this exponent is telling you it's actually 3 places greater. If this is 10 to the 4th power, that means it is 4 places larger. This one would be 2 places larger, because 10 to the 2nd power would be meaning to go 2 places. 10 to the 3rd power means you're going to go 3 places. So that is why 10 to the 3rd power also works with the place value chart. All right, next one. This one from here on over, I want you to do it on your own. So please pause this and try it. And then when you are done trying it, then you can pause it to see the answers and see if you got it right. So at least try it and see if you got it right or not. Okay, so those of you who tried it, which should be everybody, let's see if you are correct. So the exponent of this would be the base is 10, and then it was written 3 times. So it'd be 10 to the 3rd power, which is exactly how I said it, 10 to the 3rd power. Ten to the 3rd power would be how you say that correctly. Next, the exponent here, exponent form would be 10 again is the base, and then what, so if you need that, this is the base, by the way, and then exponent would be how many times it has been written. 1, 2, 3, 4, 5, so it would be 10 to the 5th power, and that is exactly how you are going to write it. 10 to the 5th power. So next, what is the value of this? Well, you could do it, you know, writing it out like this and doing that, or you could do the quick way. That is fine. Writing a 1, and then this is how many zeros you add. 1, 2, 3, 4, and then 1, 2, 3, comma. So your answer is 10,000. Next, this has 2 times, now we got to figure out what this is. That is a 1 with 3 zeros. So that is 1,000. So what is 2 times 1,000? You should be saying that is 2,000. Next, here, this is a 1 with 4 zeros. So that would be 10,000. Then times 6 would be 60,000. So those are the answers to you on your own problems. Next, the next thing I want to go over is you're going to complete this pattern with me. So here it's saying 10 to the 0 power. Well, remember that means a 1 with no zeros. So that is also saying 10 times 1, which is right here. 12 times 1. So 12 times 1 is 12. Next, how you would write this out is you would just write out 10 one time times 12, or quick way, this is a 1 with 1 0, then times 12 is going to be, how many zeros are at the end of these numbers? There is just 1. So you could write it like that, 1 0 at the end, leaving you with 12 times 1. What is 12 times 1? It is 12. So your answer is 120. Next, you could do this as well. You could write it out. That means 100. So then how many zeros are there at the end of both of these numbers together? There are 2. Do you guys see that? And then you're left with 12 times 1, which is 12. So then you go 1, 2, 3, comma. Or some people actually see a pattern even faster. They say, oh, it's 12, and then you add 2 zeros to it. That is another thing. Next, it is 12, and then you add 3 zeros to it. And then this one is a 12 with 4 zeros. So 1, 2, 3, 4. So that is something that you can see throughout the whole thing. All right, next, this one says 10 to the 3rd power equals 10 times 10 to the n power. What n power means is it means it is an unknown variable. So unknown means kind of like, you know, when you guys were little kids in 1st grade or whatever, they would do this. Blank plus 1 equals 4. So this is what a variable is. Instead of, you remember how you guys either having a blank or a question mark, now that you guys are now older, instead of a question mark or a blank, they're going to put a letter in there. That letter is known as a variable, and it's just meaning the same thing here. It just means that it is some number that we don't know. So don't be shocked by it like a letter now. You're going to start seeing letters all the time. So what they're saying here again is in order to get 10 to the third power, you're going to take a 10 and times it by 10 to what power? So if you thought about this, I need to get to 3 10s, correct? So 10 to the third power is a 10. We already have that. And then how many more 10s do I need if I already have one of them? You would need how many more? So you would need 2 more to make 3 10s. So what is missing was 10. 110 was already written down. Keep that in mind. See how there was already 110? So you can't add that to it. So what is missing is 2 more 10s. So it would be 10 to the second power. Remember, this is how you could also write that. So that missing number there, that variable, the number can be inserted once we figured it out, and we did figure it out. So n is going to equal just the number 2. So that is what should have been there. So the n should have been 2. Okay. So this one says, explain how to write 50,000 using exponents. All right, so here's the thing. You can separate them as 5, right? And then you can actually separate the rest. 5 times 10,000 will get you 50,000. You could do that. So here you could do 5 and then 10,000. 10,000 has how many zeros? That is 1, 2, 3, 4. So you would write 10 to the 4th power times by 5. Also, the other thing you could do is you can easily have taken that out, and then you would just say, right now I need something that will give me 4 zeros. So then you could automatically skip past that and go to 10 to the 4th power will give you your 4 zeros and then times it by 5. So that is another way you could go about doing that. So this would be your true answer. Next, 1 year, Mr. James travels 9 times 10 to the 3rd power miles for his job. The next year, he traveled 1 times 10 to the 4th power miles. How many more miles did he travel that second year than his first year? And explain. All right, so it already told us that he's going to be traveling more on the second year than the first year. So let's look at that second year. 10 to the 4th power times 1. So 1 times that is just going to be 1. So it would be 1 times, then we would figure out what this is. So 1 times 10 to the 4th power is, remember, a 1 with 4 zeros. 1, 2, 3, 4. So that comes out to be 10,000. So this comes out to be 10,000. 10,000 miles. Now they're saying now we got to figure out what 9 times 10 to the 3rd power is. Now remember, the quick way is saying, okay, this is actually saying 3 zeros, so we can skip all that work, and then timesing it by 9, which just bring the 9 over, so it'll be 9,000. So, or if you wanted to, you could say this is a 1 with 3 zeros, then times 9, 9 times 1,000 is 9,000. There's several ways to get that same answer. So the answer to this is 9,000. So they wanted to know how many more miles did he go the second year than the first year? Well, in order to figure out the difference between those two, you would be subtracting. So if you subtracted this, what is 10,000 minus 9,000? So you would go 0, 0, 0. Then 10 minus 9 is 1. That would be 1,000 more miles. Okay. Next page. Very quickly, we will do this. So this one says Lake Superior is the largest of the Great Lakes. It covers a surface area of about 30,000 square miles. How can you show the estimated area of Lake Superior as a whole number multiplied by a power of 10? So a whole number multiplied by a power of 10. So here we go. It says, what are you asked to find? You could say area written as a whole number multiplied by 10. All right, so how can you use the pattern? Well, you can just do this. We'll just skip that, all that work. So remember, 10 to the 0 power is a 1 with no 0, so that's just 1. 3 times 1 is 3. 10 to the first power is a 1 with 1 0, which is 10, times 3 is 30, but we're not quite at 30,000 yet, so we'd have to keep going. 3 times 10 to the second power is 10 to the second power means a 1 with 2 zeros, and then you times it by 3. So what is 100 times 3? That would be 300. Next, 10 to the third power is 3 zeros, and then a 1 in front of it, so that is 1,000 times 3. What is 3 times 1,000? It is 3,000. And then this next one is 10 to the fourth power is 4 zeros, and then a 1. So that would be 10,000 times 3 will give you your 30,000. So that's just the pattern to figure that out. However, some of you will be like, I didn't even need that. I could have just done the whole number, separated the whole number out, and then multiplied by a power of 10. And you could have. So 30,000 is, you could have said, okay, the whole number that's being taken out would be the 3. And then how many zeros do I need? I need 1, 2, 3, 4. And what would I have to multiply by to get to tell me I need 4 zeros? You could have said just 10 to the fourth power will give you that. So this is a whole number multiplied by a power of 10, and that was your answer. Okay. All right, next, the Earth's diameter through the equator is 8,000 miles. What is the Earth's estimated diameter? Written as a whole number multiplied by a power of 10. So again, it is asking you to write out a whole number multiplied by a power of 10. So 8,000. So we're going to do that as well. 8,000. So the whole number that you can pull out of this would be 8. And then you are left with needing to say times by power of 10. So we have a 10. 10 to the what to make sure we get 3 zeros would be to the third power. So this is your answer right here, is 10 8 times 10 to the third power. Next, real quick, Yolanda has 10 to the fifth power. Says that 10 to the fifth power is the same as saying 50 because you would do 10 times 5 equals 50. What is her mistake? I'm going to let you guys try and explain that real fast. So go ahead and pause this and try and see what that mistake is. And then we'll get back and talk about it. Right, so when you are done, you could say, well, 10 to the fifth power does not mean to do 10 times 5. It actually means to write 10, that base, 5 times, and then multiply it. So if you did it correctly, if she did it correctly, it would have been 5 zeros with a 1 in front of it. So therefore, it would have been 100,000. All right, now, here is the next thing. You will have homework on this one. So you are going to do 2. I know they say this weird in this, so be aware. You can also say 10 to the third power and be right as well. They're saying the third power of 10. I'm just not one to say it like that. So if you want to say the power first, you can, or if you want to go with the base first, you can say that as well. So it is how you want to. Either way is fine. So you will have number 2 for homework, write the exponent form and the word form. I am going to do this one with you. So we are going to say, how do you do this in exponent form? So the base that's being used every time is 10. And how many times is it written? It was 4 times. So how do you say this in words? You would say 10 to the 4th power. Okay, next, I'm going to have you do 4, 5, and 6 for homework. Now, I do want to do this one with you. So again, you would do here, you would go 10 to the 0 power. Well, remember 10 to the 0 power means a 1 with 0, 0. So that actually just means it is written as it is. It means 1. Then you bring down everything else. So what is 8 times 1? It would have been 8. Also, you are going to do 9 for homework. We are going to be doing 8 together. So 8 says the moon is about 240,000 miles from Earth. Write this distance written as a whole number multiplied by a power of 10. So multiply by a power of 10. So the whole number, you can pull out the whole number here, the whole number other than the zeros. You take everything but the zeros, it would be just 24. And then you can times that by how many zeros you need to add. 1, 2, 3, 4. So you would say 10 to the 4th power. So that is how you would do that. You do not have to worry about 10. You won't be doing that. Next on this is number 1. I am just going to do with you just because of the, it is being, my phone keeps, there we go. It wasn't focusing. Here we go. So this is weird how they say it. So I don't want anyone to get confused by the way they're saying it. It says, write the expression that shows 3 times the 6th power of 10. Remember, I say I don't like the way that they word that, but you can always say it the power first and then 10, or you can write the base first. You can say the base first, then to the power, like I do. But since this is weird how it's saying it, we can just do this one together. So 3 times. All right, so 3 times. Then it says the 6th power of 10. So what that means is you're going to still write 10, and then what is its power? It is 6. So that's just a way to do that. You will have 2 for homework and 3 and 5 and 6. And now you're going to say, well, Ms. Berg, you just missed one. I know that. I did that on purpose because I want to go over this with you. Mary Lou buys a package of 500 jewels to decorate 4 different pairs of jeans. She uses the same number of jewels on each pair of jeans. How many jewels will she use per each pair of jeans? All right, so you guys, this is a 4th grade standard, but I don't know if Mr. Brian had showed you it, but I am going to kind of show you. It is going to be your division. You should have said, all right, I should have taken my 500 jewels and divided it for 4 different pairs of jeans. So it should have looked like this. Now, I don't know if he taught you how to divide yet, but I will just give you a quick little lesson on it. I have a little saying, it's kind of crazy, but you guys remember the silly things. So it's called dead monkeys. Monkeys stands for times. Smell, that means a subtraction. Crazy, so crazy means check, and I'll go over that in a minute. Bad means bring down. And then when you bring down a number, you start back up at the top, and you keep on repeating until there are no more numbers to bring down. So can a 4 go into 5? Counting by 4s. 4 times 1. 4 times 1. That is 4. Is that still lower than 5? You should be saying yes. Now, if I did 4 times 2, that would be 8. Can 4 go into 5 2 times? Well, no, because then it would be too big. So they want to know how close, going by 4s, will you get to 5 without going over 5? And it was 1 time. So you do 1. 1 times 4 is 4. Subtract it, that would be a 1. Sorry, I went way too fast. So I'm sorry, you guys, forget that you guys probably don't know this. So next you should have multiplied. 1 times 4 right here is 4. So you put that right underneath that number. Then you subtract those, which is a 1. Now, what does this check mean? It means to make sure that it is smaller than your divisor. If it is not smaller, that means you did something wrong. So that is why I always put in a check so that you know to check it before you move on. Is 1 smaller than my divisor 4? Yes, it is. Okay, now I can bring down the next number. And you can only bring down 1 number at a time. So now it is saying, all right, now how many 4s can go into 10 without going over? So 1 4 is 4, okay, that's good. But can we get any more without going over 10? Yeah, we can do 2, and that would be 8. That's still smaller than 10. So far it can go in for sure 2 times. Now you can say, all right, well, let's try 3. 4 times 3 is 12. Oh, now I went over my 10, so that's too much. So therefore, how many 4s can go into 10 without going over 10? It would be 2 times. So I'm going to put the 2 up here. 2 times 5. Now I'm going to multiply. 2 times 5 is, 2 times 4, 2 times 4 is 8. So I'm going to put that underneath. Then you're going to subtract. 10 minus 8 is 2. So now I check. How many 2s go into 4? Check and see, is 2 smaller than 4? Yes, it is. So since it is, that means I did it right, because it should not be bigger. Now, if it's like a 5, that means that you did something wrong right here. It could have gone up 1 more time. So since it is smaller, that means we are on the right track. So now it says, is there any more numbers to bring down? In this case, yes, there is. There is another number that needs to come down. So now when you bring down a number, you start back up at the top. How many 4s now can go into 20 without going over? So you can say, all right, 4 times 4 is 16. And then you say, okay, it's getting closer. I can go in at least 4 times now without going over. Now I should try 4 times 5. Well, 4 times 5 is 20, which is exactly what you wanted. So how many 4s go into 20? You can do 5 4s. So you would put 5 up here, 5 times 4, because that's the next thing you do. 5 times 4 is 20, so you put it under here. Then you subtract like this, and that, then you check, you have 0, which is exactly what you want. You don't want a remainder, so that means it goes in perfectly 125 joules per gene. So therefore, we're going to write that down, 125 joules. Right, so that is how you do lesson 1.1. And I'm going to stop right now, and then I'll get back with you on the next one.